Hello and welcome. Today's video is going to be an indicial equation, a little bit different than the normal stuff that you're likely to see. Okay, so 3 to the power of 2x plus 5 to the power of 2x, the whole thing over 34 is equal to 15 to the power of x minus 1. Okay, how do we solve something like that? Well, a couple of obvious steps, first of all. So times the 34 across. Then it's worth noting that, first of all, we've got a problem. The problem we got is, of course, this plus. We cannot really do anything with these indices. It's worth noting the 3 and the 5 are the two factors of 15. So that might give us a clue. There's some kind of quadratic hidden in there. So apologies for my cough, as per usual. Today is particularly bad. So we're going to write it 3 to the x all squared plus 5 to the x all squared. The 34, we leave it for the time being. Now we got x to the minus 1. So we're going to write it as 15 to the minus 1 times, let's put the extra step, since I put that extra step in there. And this now produces something which we kind of might be getting us somewhere. This is going to be times 1 over 15, of course. And this we can write as 3 to the x times 5 to the x. So I've got these repeating terms, 3 to the x and 5 to the x, which it'll be helpful if we could perhaps replace them at this stage with an a and a b or something. So we can say a squared plus b squared is equal to 34 over 15 a times b. So the a stands for 3 to the x and the b stands for 5 to the x. And of course, an obvious step, times the 15 across and move this AB. So minus 34AB plus 15B squared is equal to 0. Now, this is a quadratic in A and B. Does it factorize? I cannot see a factorization for that. It's not that easy to see, but if we try, for example, because that's the only way really we could get some joy, let's say a 3a and a 5a to make the 15a squared, and this one, it has to be similar. Of course, we cannot have, of course, a 3b here because that would be a common factor and the whole equation would have had a common factor. So it's probably a 5b and a 5b, and this have to be minuses in order to make this positive and this negative. And let's just check. Of course, that's the that works, that and that term. I just want to check, of course, is the 34ab. That is the problem. 24ab negative from this bit here. And where's the other ab? The other, oops, I put that's a mistake. And there should be a 3. And the other one should be a minus 9ab. So it's minus 34ab. So that does work. Just double checking the other ones. That's because you saw I made a stupid error there. 15a squared. And that's, of course, 15b squared. So that does factorize correctly. Pardon me. So there are two possibilities in here. So your a from this bracket here equal to 0, of course, is either 5/3 of b, or your a is equal to 3/5 of b. And what does that mean? Well, remember what a and b stand for. So we need to create a little bit of space. And I think we're practically at the end of this equation now. a little bit unusual. I wrote this for one of my special papers, actually not that long ago. When I say not that long ago, maybe 3 or 4 years ago, remember it. Very easy to make. You start obviously from the factorization and you work your way backwards. Okay, I'm just want to check that my tablet is still in view and everything is all good. So okay, so we're gonna treat each of them separately. So A is 5/3 of B, and A is 3/5 of B, and we're going to put, of course, what A and B stand for. So the first equation says 3 to the power of x is equal to 5/3b, which is 5 to the power of x. So if we times across, we're going to get 3 to the x plus 1 is equal to 5 to the x plus 1. And by inspection there, x has to be -1, so they're both to the 0, so they can balance. Or if you cannot quite perhaps see it, do an extra step. So you can actually say 3/5 to the power of x plus 1 is equal to 1. And of course, the only way you'll get 1 by raising some power, it means that x plus 1 must be equal to 0, so x is equal to -1. So that's what I was referring here in this line here. The only way you can balance this thing here is by x being -1. And I think probably be some kind of symmetrical solution here, maybe a 1 there or something. So A is 3 to the x is equal to 3/5, and the B is 5 to the x. This time 3 to the x divided by 3 is equal to 5 to the x divided by 5. So that's going to be 3 to the x minus 1 is equal to 5 to the x minus 1. And similarly, you can either write the whole thing down, or you can just say, okay, x is equal to +1. So this particular equation has two solutions. You can easily verify these solutions by substituting back into the equation. They both work, they're both fine. And that was quite a different indicial equation. Not that easy to actually deal with it. It's in one of my special papers, so that tells you about the difficulty that students generally would have had with something like that. I hope you enjoyed the video. I'll see you real soon. I'm signing out. Bye for now.